Okay, section 6.1 video part 2, to close out this section. I want to talk about how to multiply rational expressions. Now, we talked in the last video what a rational expression is. It's just simply a polynomial over a polynomial. What I want to talk about in this section is how to multiply two rational expressions. But before I do that, let me remind you of something I showed you probably the first or second day of class. Let's suppose I wanted to multiply these two fractions. Now, is a fraction a rational expression? Yes, it is. Because 10 and 9, by definition, are polynomials. So this is a polynomial over another polynomial. So what you're looking at is really multiplying rational expressions. Now, do I call this multiplying rational expressions? No. What I call this is, I call it multiplying fractions. But that's the same thing. But what do we do here? We still, remember we talked about cross-canceling first? You find a factor that goes into 9 and 15. Well, what goes into 9 and 15 evenly? What factor? 3 does. So 3 goes into 9 3 times. 3 goes into 15 5. Then we ask, is there any factors that goes into 10 and 8? Well, 2 will. 2 goes into 10, 5. 2 goes into 8, 4. And then whatever's left, you multiply together. Now, could you multiply it first without canceling the factors? Sure you could. But it makes it a whole lot easier to cancel your factors first. Now, what we're about to look at in just a minute is I'm going to give you a polynomial where you have one polynomial times another polynomial. That's what the problem's going to look like. But it's going to have some x stuff up here and here and here and here. And so what we're going to do first is we're going to cancel the common factors first. Well, how can you cancel the common factors unless you know what the factors are to begin with? Well, how do we find the factors of it? We factor it. So in other words, here's what we're going to do. A while ago in the last video, we just had one fraction. And what did we do? We factored the top, we factored the bottom, and we canceled. Well, we're going to do the same thing now, except you don't just have one fraction now, you now have two fractions. So when we go to multiply these problems, we're going to factor, 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 and cross-cancel first, because that makes it easier. Now, let me remind you of something else that you may have forgotten, and we have not talked about this semester. Remember from elementary school or whatever, when you are dividing two fractions, the teacher probably said something like this: keep, change, flip. And so what you do before you work the problem is you would keep the first fraction the same, change the division to multiplication, and you flip the second fraction. So whenever you're dividing two fractions, you keep the first fraction, change the multiplication, and then you flip it. Then you cross-cancel. So if I'm dividing fractions, I keep, change, flip first, then I cross-cancel. But you don't cross-cancel from here. You have to do it, rewrite it like this before you cross-cancel. I'll show you what I mean by this in an example in just a minute. Before we do that, let me give you a note. Title this note, write this down. Title the note, Multiplying and Dividing Rational Expressions. Multiplying and dividing rational expressions. 3 steps. Here are the 3 steps. Step 1. If we are dividing, keep, change, flip. That's step 1. Step 2. And you pause the video as you need to. Step 2. Completely factor every numerator and denominator. Completely factor every numerator and denominator. And then step 3, cancel common factors and negative factors. Cancel common factors and negative factors. So really the only difference in the multiplying and dividing rational expressions and in simplifying rational expressions is the first step. If you're dividing, you flip the second fraction over. And then you've got 2 numerators and 2 denominators to factor. So factoring and canceling stays the same. Okay. Let me just show you 2 examples of this because it's the same. So let's look at this one. Okay, so here's the problem. Now, multiply and simplify. But let me say again this. I don't want to start multiplying all of this out first. Because how do we multiply 2 fractions together? Cross cancel first. Well, you can't cancel until you factor. So, the 3 steps you just wrote down a while ago. Look at the first step. If we are dividing, we're not. So you can skip that step. Step 2, completely factor every numerator and denominator. So I want to factor, 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 factor. All right, let's do that. Okay, so this will be 2. All right, let's factor this. The difference of 2 perfect squares. X plus 3 times x minus 3. All right, let's factor x plus 2. It's a binomial. There's no GCF. It's not difference of squares, and it's not sum or difference of cubes. So that won't factor. It just stays x plus 2. No, you don't have to put it in parentheses. I just did because it didn't factor. Times. This is the difference of 2 perfect squares. X plus 2 times x minus 2. Now this one. Binomial. Does it have a GCF? Yes, 5. So take out a 5, and when I do, I'm left with x minus 3. Now, I want you to know, so all I did going from here to here was factor. Have we already covered factoring? Yes. So going from here to here is not anything new. Now, the only new part is canceling. Well, watch, and I want you to watch how simple this is. This x minus 3 cancels with that x minus 3, and it leaves 1s. This x plus 2 cancels with those x plus 2, that x plus 2, and leaves 1s. So look at what you're left with in the top. X plus 3 times x minus 5. Look at what you're left with in the bottom. 1 times 5 times 1, which is 5. And that's your answer. Now, there would be nothing wrong if you chose to multiply this back out, but we typically don't. When we're multiplying rational expressions, we factor everything and cancel, and then whatever's left, we just leave it intact like that. Okay, let's do one more. Okay, first notice we are dividing one rational expression by another. All right, the steps in multiplying and dividing rational expressions. Step 1, if we are dividing, and we are, keep, change, flip the second fraction. So that's the first step. If we're dividing, keep, change, flip. Now step 2, factor every numerator and denominator. Okay, x squared minus 9. The difference of two perfect squares. 2x minus 10, GCF of 2. All right, now this one, x squared minus 2x minus 15. Trinomial, no GCF, easy case because of the 1. So the x squared breaks up as x times x. Signs are different, largest is negative, so the biggest number is going to go here. Two numbers multiply 15, subtract 2 is 5 and 3. And then the bottom, 3 minus x, won't factor. There's no GCF. It's not difference of two perfect squares. Now, cancel common factors. This cancels with this one, leaves 1s. Now, you can't cancel the x plus 3's because they're both in the top. But you can cancel the x minus 3 and the 3 minus x. What did we say about those? Those are negative factors. So that leaves a negative 1. So here's what I'm left with. In the top, x plus 3, and then I can either put another x plus 3, or I can just write that squared, but don't multiply it out, over 2, 2 times 1, and this is 1. But you still got this negative in the top, and I told you typically what we do is we just put it in front of the parentheses. But don't distribute it through because of the exponent there. You can't. So that is the answer to that problem. So that completes section 6.1, simplifying rational expressions, and then multiplying and dividing rational expressions. You simply factor everything and then cancel. If there's a division symbol, you keep, change, flip, but you still factor everything and then cancel. So that concludes this video, section 6.1.